Okay, guys. So, one of the most important subjects asked in the UPSC CSE prelims is, of course, environment. I mean, since the Forest Service exams also occurs with the, all Forest Service also has the same prelims as civil services examination. So, therefore, environment is a very important chapter, right? Very important, subject. So, let us begin. So, we are studying Shankar IS. I have with me this, this 2018 edition. 2018 edition, okay, of Shankar IS Academy. Just a second, guys. Right. So let us begin. Uh, Coral reefs is an important topic. Remember, coral reefs. It is an association of corals with zooxanthellae. Zooxanthellae provides them the color, and yeah, that's about it. Functions of coral reefs: they provide substrate for mangroves, and they are the largest biogenic calcium carbonate producer. What this means is the calcium carbonate is produced by coral reefs, and in fact, they are the largest biogenic sources of the calcium carbonate. Right. Threat is normal coral bleaching. Coral bleaching is obviously if the stress is too much, then zooxanthellae separates, and if it is for long, then it becomes irreversible. Okay. Causes of coral bleaching, I think that everyone must be aware. Temperature is the major cause of coral bleaching. Temperature means both high and low. That is, extremes of temperature are harmful. Both high and low. So extremes of temperatures are harmful for the coral reefs. Solar irradiation. So while coral reefs generally occur in the shallow seas, they are also we need to take care is that they do not get exposed to the sun's radiation directly. That is also harmful to them, right? What else? Freshwater dilution. What is the meaning of this? It is freshwater dilution. It's one of the causes of coral bleaching. Basically, this means is rapid dilution of the reef waters from the storm generated precipitation runoff, and has been demonstrated to cause coral reef bleaching. Basically, when there is rainfall, right, or surface runoff from the agricultural fields into the waters, and if coral reef is present there, then it dilutes the coral reef waters, right? So this can also lead to the coral bleaching. But remember, freshwater dilution is a rare thing, right? It's rare. Also, if it does occur, it occurs in a small localized area. So it is rare and localized. Okay. Next, Inorganic nutrients. Inorganic nutrients basically it's another name for eutrophication. So see, whenever nutrients are in excess, or which we call as eutrophication, it increases the zooxanthellae densities. Now zooxanthellae are organisms. If they are increased, it can cause secondary adverse effects like lowering of the coral resistance and greater susceptibility of reefs to diseases, and this causes coral bleaching. So eutrophication has an indirect effect on coral bleaching. Okay, remember this thing. Let's write this. Eutrophication, it basically increases the zooxanthellae densities, right? And some secondary adverse effects like lowering the coral resistance. And so basically indirectly, after many such steps, coral bleaching occurs. So it is an indirect effect of eutrophication, coral bleaching. Okay. Next, xenobiotics, that is exposure of the coral to elevated concentrations of various chemical contaminants. Xenobiotics, like antibiotics, xenobiotics are also chemicals, and but they are contaminants like copper, herbicides, and oil. Remember, xeno means foreign, right? Xeno transplant is there, that is transplant of different species, and here we are talking about xenobiotics. So basically, chemical contaminants, right? Chemical are xeno. Why? Because they are foreign for the plants, right? For the corals. So xenobiotics are chemicals, right? Example is copper. What else? Any other chemical, oil, etc. Whatever chemicals. Now xenobiotics basically induce, what they do is they cause zooxanthellae loss, and this zooxanthellae loss occurs only at higher concentrations, at very high concentration of the xenobiotics. So yeah, that's correct. So high concentration of xenobiotics causes zooxanthellae loss, which again results into coral bleaching indirectly. But since it is this high concentration, what is there, this implies that xenobiotics induced coral bleaching is also highly localized. So again, this is a localized thing. Just a second. Yeah, this is localized. Okay, right. Then next, epizootics. So basically, epizootics is when the involvement of pathogen occurs. Epizootics, right? Pathogen induced bleaching. It is different from other sorts of bleaching. How? Because most coral diseases are cause patchy or whole colony death and slowing of soft tissues, leaving a white skeleton. Few pathogens have been identified. Example, a protozoan. Okay. Just remember, epizootics means it is a pathogen induced coral bleaching. Pathogen induced, and pathogen basically can include anyone: bacteria, fungi, virus, parasites. Okay, right. All right. This is all about coral bleaching. This completes the chapter. Remember, we were studying this chapter 4 in the Shankar IS book, aquatic ecosystem. This is the 2018 edition that I am studying from. Next, we have the environmental pollution. Now here there is not much to study as far as prelims is concerned. Just remember this. You must have seen in current affairs many. I mean, ongoing for some years now. I think 3-4 years. NAAQS, National Ambient Air Quality Standards, right? So it has basically it covers 12 pollutants. Now not necessary to remember all 12, but if you can have some idea, like sulfur dioxide, nitrogen dioxide, PM10, PM2.5, ozone, lead, carbon monoxide, nickel, arsenic, benzene, ammonium, and benzopyrene. Now please remember, there is no CO2. So among these 12, there is no CO2. This is how you have to study for prelims, right? You don't have to remember everything because no one is asking you to write, all the 12. But they'll ask you which is not. So elimination, for elimination, you need to know which are the common pollutants that are very common, although they are very common in the environment, but they are not included in this criteria, right? No CO2. Also, I also made a mnemonic for some of the pollutants, like SO2, NO2, and PM2.5, PM10. I think everyone can remember, and everyone does remember, right? For the remaining pollutants, at least for some of them, the mnemonic is ban AB, right? So here, benzene, arsenic, nickel, ammonium, and benzopyrene. So this covers 5. Okay, 4 I have already told you: NO2, NO2, SO2, PM2.5, PM2.10. That makes it 9. 3 more are ozone, lead, and carbon monoxide. Ozone we know is O3, lead plumbum, and carbon monoxide CO. Right. So basically, this completes our 12 pollutants. These are the 12 pollutants that are monitored under the NAAQS. Right. Low probability of being asked because no current update is there, and this NAAQS has evolved, I think, more than 10 years back. So yeah. Okay, then moving on to the next topic. National Air Quality Index. So this was NAAQS, then we have NAQI or AQI. This, if you read newspapers you must have seen, every day the air quality index of the respective city is highlighted. So it has 6 categories: good, satisfactory, moderately polluted, etc., etc. Distinct color schemes are there, and this monitors 8 pollutants. So for us, this can be important. 8 pollutants. So now what are these 8? See, 4 I told you, it's very common, and you should always remember which are those 4: SO2, NO2, PM2.5, and PM10. These are the 4 that are also there in the NAAQS, right? The other 4 are ozone, lead, carbon monoxide. These 3 also we studied, right? And one more. Now remember, there we studied BANAB, ban AB. See this ban AB. So instead of these 5 pollutants, AQI monitors only ammonium. So basically that means this N is common again. So BA and AB, these are only there in the NAAQS, right? Okay, just a passing knowledge. Okay, it's not very high yield though. Next thing important in this chapter is, this concept, very important. I think questions have already been asked and they can be asked again. The dissolved oxygen, biological oxygen demand, and chemical oxygen demand. Very, very important concepts from environmental perspective. So what this means is, dissolved oxygen, as the name suggests, what is the content, what is the amount of oxygen that is present in a given water body. Any water body having the DO content, DO less than 8 milligrams per liter. This means it is a very low level of oxygen, so it is considered as contaminated. This water body is considered as contaminated, right? This is about DO. And if it is less than 4, then it's highly polluted. So basically, dissolved oxygen is as much higher is there, it is better for us. More dissolved oxygen, that means better for the living aquatic organisms there, right? The demand for oxygen is directly related to the increasing input of inorganic waste. Now, this is all about DO. Now, what about BOD? This is the most important thing. Biological oxygen demand. Basically, as the organic content of the waste increases, the demand for oxygen also increases. Okay, because more oxygen is required to decompose organic matter. So basically, the higher amount of waste increases the rate of decomposition oxygen consumption, therefore decreases the DO content of the water. So BOD is inversely proportional to dissolved oxygen. Since the more the organic waste, the more the demand for oxygen. The more the demand for oxygen, the less the dissolved oxygen, right? So please remember this relation, which means BOD, if it has a high value, it is harmful. So just opposite to what dissolved oxygen we studied for dissolved oxygen, right? And I explained just now why. So BOD is the amount of dissolved oxygen that is needed by the aquatic organisms, by the bacteria to decompose the organic waste in the organic material in the waste, right? Now BOD is only limited to the biodegradable materials. So this is an important limitation of BOD, only biodegradable materials, biodegradable, right? Okay. So therefore, and hence comes the need of COD. So because BOD is a very comprehensive measure, I mean it's very good, but then it doesn't measure the non-biodegradable component. So we require another metrics, and that for that we have COD. It is a better matrix to measure the pollution load in water, because it measures the measure of oxygen equivalent of the requirement of oxidation of the total organic matter, right? So this is more comprehensive, you can say, in easy language, more comprehensive. And this is all about these three metrics, very important: dissolved oxygen, BOD, and COD, right? So you can say this also: COD as well as BOD both are inversely proportional to dissolved oxygen, right? Because it's the same concept. Oxygen equivalent is seen in COD, right? This is about these three. Okay, next let's see, pollution is very important. So yeah, I mean some of the toxic elements, their their sources and their health effects have been given from Shankar IS. I don't think it's very important. I mean, if it's in current, you can, and you will anyway study from the current affairs, right? Yeah, toners, that is the plastic print, whatever the printer cartridge that we have. So for that, they can also contain carcinogenic material. Actually, carbon black has been classified as class 2B carcinogen, which makes it harmful, possibly carcinogenic. 2B carcinogenic means possible carcinogenic. So just a passing reference: toners in the printers, they carbon black is there. Carbon black, this carbon black is a class 2B 2B carcinogen, and class 2B carcinogenic means it is possibly carcinogenic, possible possibly carcinogenic, right? Okay, right. E-waste, not much, as Mumbai is the has the highest range generating e-waste, right? Not much of an achievement though. Then 10 states generate 70% of total e-waste. Yeah, inequality is there in India. Okay. Now just a fact. I mean, it's actually off the topic. Science Express was an innovative train by the this was built for the Ministry of Science and Tech by Indian Railways. So here all the ministries have combined, and it was in 2009. So not much relevant right now. Let us see. Plastics. Now about plastics. Now there are two differences between the fate of plastics debris in the ocean environment as opposed to land environment. So basically, plastics, it's indispensable for human use. I mean, only now we have begun to realize its harmful effect, and now many legislations have been brought in to control the plastic waste. But they are still used, omnipotent actually. So plastics, they can either remain on the land, or they can be, found in the environment, ocean environment. So land or ocean. Now, what is the difference is that on the land, the rate of UV, that is ultraviolet rays induced photooxidative degradation of the plastics is higher, right? So but in the oceans it is very slow. So this means, what this means is that plastic debris is expected to remain for a longer time in the ocean because of the slower rate of the ultraviolet induced photo-oxidative degradation of the plastic debris. Secondly, unlike on the land, there is no easy means of retrieval, sorting and recycling of the plastic waste that enters into the ocean environment. Obviously, see, ocean environment means you'll have to uh, go through expensive or high-tech ships and all for retrieving, sorting and recycling of plastic waste. So it becomes difficult compared to on the land, where we can just pick it and sort it. So this results in extended lifespan of plastic debris in the ocean, and that is harmful, right? Next is microparticles. So plastics are okay. Plastics are bioinert, not expected to be toxic to anyone in the conventional sense. The concern, however, is that plastics exposed to seawater tends to concentrate toxic and non-toxic organic compounds present in the seawater at low concentration. These, including PCBs, DHAs, and nonyl phenols, have very high partition coefficients and very efficiently concentrate in the plastic material. So basically, this topic is telling about how the plastics are harmful for us. So although they are not toxic, generally they are not toxic because they are bio inert. But what they do is they concentrate organic matter. Now this organic matter can be toxic. So they concentrate toxic organic matter called compounds, which are toxic, but these organic compounds are found at low concentrations. Uh, Low concentration, right, in the ocean, in the water bodies, ocean. So when they are present in the ocean, these toxic organic compounds are not much of a concern, at least not for the humans, right? But when the plastic is also there, so what plastic does, it concentrates it concentrates these toxic organic compounds, and this results into something we call as biomagnification, bioaccumulation, and that causes problems for us. So that's why plastics in oceans are more harmful than the plastics on land. So we have seen three reasons, right? Two reasons support why plastics remain longer in oceans compared to land, and third is why plastics on ocean are directly more dangerous than the plastics on land, because plastics in ocean bioaccumulate, biomagnify the toxic organic compounds. All right, this reaches us to the completion of this topic. Then the next topic in the pollution only is acid rain. Okay, acid rain, I think not much to there is there. Just remember there are two types of acid deposition. After the acid rain, there are two types of acid deposition. If wet and dry. Wet deposition is if the acid chemicals in the air are blown into areas where the weather is wet, the acids can fall to the ground in the form of rain, snow, fog, or mist. Right? I mean, it doesn't have to fall in the form of liquid. Sorry, I mean it doesn't have to fall in the form of in a dry form. It can fall it can fall into the wet forms, right? Okay. So precipitation removes gases and particles from the atmosphere by two processes: rain out, that is incorporation of particles into cloud drops, which fall to the ground, and wash out, which occurs when materials below the cloud is swept down by rain or snow it falls. I don't understand if these are very important or not. It basically talks about acid rain and how the deposition happens. Two types of deposition happen: wet and dry. In wet deposition, rain removes the gases and particles from the atmosphere. Rain removes by two processes: rain out and wash out. Now rain out means particles are incorporated into the cloud drops which fall to the ground, whereas washout means materials below the cloud is swept down by rain or snow that falls, right? So if particles are incorporated into cloud drops, then they later fall to the ground. That is known as rainout. And if the particles material below the cloud is swept down by the rain or the snow that falls, it is washed out. Okay, not don't go into much detail. So this is about wet deposition. Dry deposition is where the weather is dry, the acid chemicals may become incorporated into the dust or smoke, right? Fall to the ground through dry deposition, sticking to the ground. So basically, uh, wet means in association with the liquid, right? But dry means just dry. Now this is around 50% of the acidity in the atmosphere falls back to the earth through dry deposition, right? Okay, so this is about this. Next we have again random fact: the banana tree is has only a thick false stem. So basically, banana tree is not a tree; it is a giant herb. Banana, banana is a herb, right? It's not a tree, and it has a thick false stem. It is pseudo stem. It is not woody, but made up of a central coat of soft tissues concealed by fibrous and sheathing base of large leaves. Right. Now, uh, acidified lakes. So there is a difference between naturally and anthropologically acidified lakes. Natural lakes are brown. Acidic lakes are brown to yellow color, right? Caused by humic substances. The concentrations of dissolved organic carbon are high, while the transparency is low. They have low pH, obviously, since they are acidic, but well buffered, and they are abound with aquatic life. These things will most likely be reversed in the anthropologically. Well, let's see. So first, acidic, naturally acidic, and anthropologically. Anthropologically. Okay, good. So as far as naturally acidic are concerned, lakes are concerned, it is discolored. We are talking about lakes. Just a second. We're talking about lakes. All right. So they are discolored. These are not. Okay, anthropologically are very clear. Okay, this is caused by humic substances. This is caused by reduced primary productivity. Here, concentration of dissolved organic carbon. So dissolved carbon is high. Here it will be low. Transparency, since it is discolored, you can obviously conclude that transparency will be low. So transparency is low. Here, since clear water, transparency is high. All right, logical. Now this is, since it is natural, it will be well buffered. This is also common sense, and this anthropologically is poorly buffered. And finally, they are abound with aquatic life. So aquatic life is abundant, you can say. Aquatic life present, right? Anthropologically, not so much. So these are the major differences between the two. Yeah, naturally acidic and anthropologically acidic lakes. Yes. Discolored dissolved carbon dioxide is higher, since their discolored transparency is low, but they are bound with aquatic life. Also, they are well buffered, right? Caused by humic substances. This is caused by humic substances, whereas anthropologically acidic lakes are caused by reduced primary productivity. Okay. Another random fact: agamospermy. So it is a botanical concept actually. But since it's given here, let's study it. Okay. Agamospermy. Right. Basically, sometimes seeds of a plant are formed without fertilization. Right. So that is there. This phenomenon is known as agamospermy. It is also we can understand it like a parthenogenesis thing, right? Where the in parthenogenesis fruit is formed without fertilization. Example, pomegranate, I think. So yeah, so agamosperm is seed formation without fertilization. Seed without fertilization, somewhat like parthenocarpy. All right, okay, just a random fact. Finally, the last thing of this chapter, industry categorization of industrial sector. So basically, Ministry of Environment has developed the criteria of categorization of industrial sector, and the various color for categorization are red, orange, green, and white. So there is no yellow. Red, orange, green, and white. There is the pollution index. Now, what is pollution index? It is a function of the emission, that is air pollutants, water pollutants, hazardous waste generation, and consumption of resources. The pollution index is is a number between 0 to 100. 0 to 100. So PI, pollution index, ranges from 0 to 100 depending on the pollution, 100 being the highest, most polluted. Okay, so not much here. Yeah. So this completes this chapter. Next is renewable energy. Not much is there. I'll go directly to the EIA, that is 8th chapter. Now EIA is a very important topic, not just for prelims, also for mains, because recently it was also amended. So this makes it important. It was amended in 2020, I think. EIA. So there is a beautiful diagram given in Shankar IS on the first page only of this chapter. So basically it says, I'll just explain this. See, this is the environment, and this is time. With time, what changes are happening. So a project is initiated here, right? And this is the adverse impact. This is the adverse impact due to the project. Adverse impact. However, if we do not initiate any project, so this is without project. This is the impact without project. This is straight line. Okay, this straight line is without project, and this dotted line is with project. So any project that will operate will obviously impact environment in some harmful, some negative way. So this is the adverse impact. So this is A, and here this is without EIA. Project without EIA. Now in let us draw another one. In B, same y-axis is environment, x-axis is time. This is project. This was the impact of the adverse impact of the project, right? This was without project. But what we do with EIA is, with EIA, this becomes this. So this is the adverse impact is reduced. This is with EIA. This is without EIA. And this is without project, right? So there's obviously, if there's no project, that's the ideal scenario as far as environment is concerned. But we also have to think about economy. So this, so whenever a project is initiated, it should always follow EIA, because that significantly reduces the adverse impact on the environment, right? All right. So because of this, government notified the EIA, and it was brought under the provisions of EPA, that is Environment Protection Act 1986, right? So it's also useful for me is these two diagrams, right? I have just drawn from Shankar IS, this rough diagram. Okay, so what else do we have to study in EIA? Yeah, we need to know in detail how does the EIA function, what are the various components, right? Let us see those. Okay, and this will be the last thing from this unit. Okay. So 2006 amendment. So basically, like I said, they came into force for the first time in 1994. 1994. So after this amendment came in 2006, and now in 2020. Okay. So 2006 amendment. It has decentralized the clearance projects by categorizing the developmental projects in two categories, category A and B. right? So by 2006 amendment, decentralized the clearance, right? Two categories, category A and B. Category A are appraised at national level by the Impact Assessment Agency and the Expert Appraisal Committee, and category B appraised at the state level. Okay. So also after 2006 amendment, the EIA comprises of 4 cycles. EIA cycle comprises of 4 stages. 4 stages of EIA. Right. What are the 4 stages? Screening, scoping, public hearing, and appraisal. Screening, scoping, public hearing, appraisal. These are the 4 stages of EIA introduced after the 2006 amendment. Okay, coming on to back to the categories. Category A, appraised at national level, they require mandatory environmental clearance and do not undergo the screening process. So screening is not for category A. Screening is only for category B because A are sensitive projects, category A, and therefore they are not subject to screening. Category B are undergo screening, and why do they want? Why do they undergo screening? Because further categorization is done. B1 and B2. B1 mandatorily require EIA, B2 doesn't. So further differentiation is done, right? So basically, as a whole, category A and B1, these undergo mandatory EIA clearance, whereas B2 doesn't require EIA. And for A, the clearance is given by at the central level, and for B1 at the state level. All right. Now, 2020 amendment. So in the 2020 amendment, first of all, the time for public hearings has been reduced from 30. So from 30 days to 20 days for public hearing, right? Then we have exemption of projects. So see, we just now saw that B2 projects don't require EIA clearance. So many projects have been put under under B2. That is known as exempted projects. So exemptions have been increased. Exempted. Right. Exempted projects like hydroelectric power projects up to 25 megawatt, irrigation projects between 2000 to 10,000 hectares of command area, offshore onshore oil, gas and shale exploration, small and medium cement plants, all inland waterway projects, and widening of highways between 25 to 100 kilometers with defined parameters, including those cutting through forests, right? Aerial ropeways, etc., etc. Then post clearance compliance, that is, once the project has been given the nod, it is also monitored after it has been given the nod. Then annual submission of reports is required now, right? Earlier it was every 6 months, so again compliance is also softened, right? 1 year compliance reports instead of 6 months, which was in the 2006 amendment. What else? Yeah. So whatever non-compliance, we just now saw post-clearance compliance is there, but whatever non-compliance is there, there will be no public reporting for that. So basically, people cannot complain about the non-compliance of the projects, non-compliance from public. So only the government can take cognizance of this thing, right? Another is post facto clearance. This is a very controversial thing. So basically, a project can continue its activities. Meanwhile, it can apply for the clearance. So whenever, so till that time it gets its clearance or is rejected the clearance, it can continue. So this is a controversial provision, and penalty for firms is there, right? This was our 2020 amendment, which has been criticized widely. Now, 2022 amendment has come recently in July 2022. So we have the 2022 amendment. So let's see what do they say. So basically the new amendments of 2022, they are again just not much amendments are there, just one exemptions are there. Many exemptions have been given to varied categories of projects, right? So let us see these exemptions. Basically thermal power plant up to 15 megawatt which are based on biomass or non-hazardous MSW, municipal solid waste, using auxiliary fuels up to 15%, they have also been exempted as long as the fuel mixture is eco-friendly. Just remember, thermal power plant to 15 megawatt, right, based on biomass. Then because to cater to the fishermen, the threshold of the ports which exclusively deal in fish handling and cater to small fishermen, they will also be exempted. Then toll plazas that need more width for installation of toll collection booths, right, they will be exempted. Expansion activities in the existing airports, but without increasing in the airport's existing area. So basically, the existing airports will have the same area, but expansion within those airports that has been exempted. For strategic importance, yeah, and highways. So basically, any highway of strategic and defense importance for which are 100 kilometers from the LOCs, they are also exempted. So many exemptions have been added, right? Yes. This is about EIA 2020, EIA 2022, EIA 2006, right? And basically what is the EIA basics. Now let us see. Urban forestry scheme was launched in Pune in 2000 early. Just a random fact. So this completes chapter 8th, that is EIA, right?